and welcome to the Microchip Is podcast. Join your host, Mike Maynard, as he learns about the technologies, products, and people that make microchip technology what it is today.
Welcome to the Microchip Is podcast. Today, I'm finding out that Microchip is rugged outdoor touchscreens. My guest today is Vivek Tyagi. Vivek is the product marketing manager for Industrial Touch ICS at Microchip. Vivek, welcome to the podcast.
Hi, thanks, Mike. Thanks for the introduction and kind words.
It's great to have you on the podcast. Can you tell us a little bit about your role at Microchip?
Yeah, so as you said, I'm the product marketing manager for the Industrial Touch ICS. What does that actually mean? So that means I belong to the team in Microchip and we design touch controllers, ICs. And these touch controller ICs are actually the technology behind the touch experience that users usually see on their touchscreens. Everybody's using touchscreens these days. If your touch screen is working perfectly, flawlessly, smooth experience, works in rain, with glove, and all of different kind of environments, touch controller is behind it. And we are the team that is actually building that experience for you and for our customers.
That sounds great. Now, we're talking specifically today about outdoor touchscreens. I know you also work across the range of indoor and less rugged ones. But, the first question is, why is it so much more difficult to make a touchscreen that works reliably outdoors?
Yeah, we know that touchscreens are now becoming part of our lives in daily lives a lot, right? People use smartphones, people use tablets and laptops, etc. But not only just that, you use knowingly or unknowingly touchscreens everywhere. You use it in a restaurant to pay on the POS machines. You use it on a ATM. You use it on a parking meter. Sometimes you use it on an EV charger. You have sometimes washing machines and fridges, which have now touchscreens. So, they are everywhere. But not all of them are easy to make, and especially the ones that are designed for outdoor use. And the reason is that the touchscreens that are going to be exposed to these kind of outdoor environments need to be very rugged. We call them unattended terminals. So there is no person taking care of them. So they are in public spaces. That means they will be exposed to harsh environment like a thunderstorm, for example. If there is a thunderstorm, then that means there is extreme rain and dust and mud, etc., that will be then exposed on the touchscreen. There could be that the touchscreen is exposed to a hot sun throughout the day, and then the temperature of the touchscreens and the components inside may rise up to 85 degrees or even more. For example, the other extreme would be that the touchscreen is used in a very cold country like Canada, and then in the winters, the temperature will go to -40 or more, or the exposure could also be to snow. And being public, they may also be exposed to vandalism, for example. So, there are a lot of challenges that are then incurred on the touchscreens that are supposed to be used outdoor and unattended. And to make a good touchscreen, a rugged touchscreen where the user doesn't feel a difference of these environments around and can use seamlessly and easily these touchscreens is not easy job. And the companies, they need to have a lot of experience in building these touchscreens. And people and companies like us should have also very, very, very matured experience on designing the ICs and touch controllers that can provide that good quality of experience to the users. These are some of the reasons why this is not easy job.
So it's certainly challenging, but you mentioned that actually the use of touchscreens is growing, and I'm sure people see that. I'm interested, what are the kind of applications that you're seeing that's really pushing the demand for outdoor touchscreens?
Touchscreens are getting popular in every segment these days. A few years back, you remember cars didn't used to have touchscreens. Now almost all cars started with electric cars, but now almost all cars have now touchscreens. And the electrification and e-mobility is, for example, one of the trends that is increasing the use of touchscreens. So with the cars, electric cars, came the EV chargers. In past few years, we have seen that use of touchscreens on EV chargers is increasing a lot. The first chargers didn't have the touch screens, but eventually the ease of use with a touch screen was much better, and the companies got this feedback and they started using touch screens. So the latest ones, at least the public chargers, will have touch screens. Most of the parking meters have touch screens, indoors or outdoors. Very recently, we started seeing touch screens on our motorbikes. The instrument cluster, the central, interface to interact with your motorbike used to have all these buttons and dials. And on any kind of motorbikes or scooters, now you start to see that there is a lot of touchscreens getting involved because people can connect their mobile phones, use Android Auto or Apple CarPlay to, directly interact with their vehicle and decide where they want to go. And these guys are also exposed and parked outside. So, a lot of these applications are now examples of where the outdoor touchscreen can be used.
And you've talked about a huge range of examples here. So presumably you're having to design controllers that can support a wide range of screen sizes.
So yeah, you're right. Depending on the equipment, the screen size will differ. If you are on a construction site as a construction worker holding a tablet in your hand, working with it in the extreme environment, the screen size could be somewhere starting around 8-inch, 7-inch, going up to 10-inch. But then on an EV charger, sometimes you will see a screen of about 15.6-inch. And if it's a big, fast EV charger and the charge point operator also wants to do some advertisement, then the screen size can actually increase from 15 to up to 20, 25-inch, for example, right? Same goes for the parking meters. Those screen sizes also vary depending on what you want to do. A ATM probably will have around 15.6-inch screen. So depending on the use case, you're right, the screen size will differ. However, when you are thinking about the experience of the touch itself and the challenges, I think they share the commonality. There is a commonality to them. And from the engineering and design perspective, you may have to think of the same problems to solve. And therefore, screen size does vary, but it doesn't matter that much in the design itself. It's actually the problems and then breaking them into the technical problems that is actually common. And you just have to have a good touch controller and a good screen to give that experience to the user.
That's really interesting that the size doesn't matter, but it's a problem. So let's dig into that problem. I mean, what's the impact on the actual touchscreen controller if you've got a problem like rain or snow, or, you've got users in the cold wearing gloves? I mean, what does that do to the touchscreen controller and the demands on it?
That's an interesting question. Let's start with basic understanding of how at least the touchscreens work, right? Without going too much into the details, the way the touchscreen actually works, it's most of the technology is the capacitive touch technology these days. And what does that mean? That means on the screen, there will be a capacitive touch sensor. It's usually not visible to the eyes. It's a transparent sensor. It's made with a transparent metal called indium titanium oxide, ITO sensors. There are transparent X and Y lines. So these are very thin wires that run across the sensor, creating a matrix. And there is some electric current that passes through these sensors. When you pass electric current through this sensor, there is a capacitance and electric field getting emanated from this type of sensor. And when you bring any kind of conductive material, for example, a human finger, it will disturb this field. And this disturbance is what exactly do you want to actually detect. And that is detected as a touch. That's basics of the capacitive touch sensing. The location of this sensor is somewhere what we call as in between the stack of the display. What does the stack mean? It means there is the screen itself, and then on the top of the screen, there will be certain layers of material that will go. It could be, for example, a glue that is gluing the glass to the screen. And then there will be another layer of glue that will glue the sensor to the glass. If the screen is exposed to a lot of sunlight, then there could be a lot of glare to the user. So there is anti-reflective coatings or anti-glare coatings that would also be needed to be glued in between. So if there is a lot of UV rays exposure, again, because of the sun, and this could actually destroy some of the material over the long term, you sometimes have UV filters also in between. So, you start to see that there are a lot of layers from the screen until your finger. And the more these layers are there, the further your finger is from the touch sensor itself. And that is exactly the problem, because the signal that needs to be disturbed from your finger is now further and further away. And a good touch controller needs to actually detect this signal very efficiently and in a very good way. And that is exactly creating the problem in this harsh environment. If the environment is harsh and you want to, for example, protect your device from vandalism, you may choose to have even a thicker glass now. If you are using a thicker glass, now this is increasing further the distance between your finger and the sensor itself. So it's the challenge of detecting a minute signal, because you're trying to make a robust touchscreen with a very thick layer, that is actually creating the problem for design of these such rugged touchscreens. That's the problem.
That makes a lot of sense. So you're trying to detect this signal, and you could have, for example, phantom signals, I guess, from rain, or the signal's even lower if people are using gloves. So how in the past have people solved this problem and overcome the challenges of outdoor touchscreens?
Exactly. So, as I said, any conductive material will actually create an impression of touch because it will disturb the electric field. When you bring a bare finger close to the sensor or a gloved finger, the finger itself is still a conductive surface. Same goes for the water. Water itself is conductive. So if it's rain, it will try to disturb the electric field and will be detected as touch. So the challenge is, how do you differentiate between these different types of disturbances? Of course, all of these disturbances will have their own pattern, and you would like to actually detect what each pattern is and then classify the touch according to that, and then discard the ones that you don't want. But this has not been always an easy solution. So if you remember, the touchscreens that used to come very, very early couldn't even solve these problems. And, if there is even a small amount of moisture, you will start to see accidental buttons getting pressed and your phone start doing other stuff. So people started looking into, well, how can we actually solve these problems? One of the ways to do this is force detection. Whenever there is a thing touching, a conductive surface is coming in contact with our touchscreen, you not only detect that there is the field getting now disturbed, you also try to see with how much force and what is the distribution of that force on that screen. Because different type of entities will have different force. For example, if I use my human finger, when I try to press it, the screen can detect the force is very located into a small area, and a human will have certain level of force. If there is water, it will be more scattered, right? It will be detected multiple times simultaneously on different parts of the screen, and force will probably not be very high. Then if it is a glove, then the surface area touching will be quite high, and the amount of force probably will be similar to finger. You can distinguish basically what is on the screen and with how much force is it trying to make the choice, and then detect what it is. But to build a system like that, for example, you have to build a technology into your touch screen, into the display itself, that can detect this force. And there are a variety of materials that comes out there, but these are quite expensive, for example, right? If you want to build something, a new technology into the body of the display itself, you will have to talk to display suppliers and they have to build physical stuff inside, and that will then increase the cost of the overall display. One of the ways that we started thinking about it from touch controller perspective is that inside the touch controllers, you can build algorithms, for example, and you can filter the signal, and you can study the pattern of the signal itself. And then you can, inside the touch controller, decide what type of signal it is. And that way you save a lot of cost by not doing actually physical modifications to your screen, but rather doing this type of sensing inside the touch controller. And that is exactly one of our major strengths, because we have one of the best algorithms out there. You don't need to build anything in your physical body, but you can use a touch controller to distinguish between this type of touches.
That's a really clear explanation. I love that. So I mean, you talk about having this ability to detect the small signal and using the best algorithm. Are there particular microchip touch controllers that are really designed to do this in outdoor applications?
Yes. So the touch controllers from Microchip, and by the way, MaxTouch is the brand. And if you are out there in the touch world, there is no way that you didn't hear about MaxTouch, because we are quite famous and we have a quite proven track record for providing touch controllers. So these touch controllers, we are constantly working through many years to improve them, and we bring them into different generations. And where we made a huge jump, and the ones that I would really be very confident in saying that these are particularly best for outdoor usage, is what we call as the TD and the UD generations. So we have 7 focus products that you can find on our website. They can help you build touchscreens, rugged touchscreens, basically starting from 5-inch going up to 25, 30-inch. And there is a touch controller for each screen size. For example, starting from 5 to 7, there is a touch controller. There is a touch controller from 7 to 10-inch. What you have to do is look for the TD and the UD at the end of the part number. So I can give you some examples like MXT 336UD or MXT 640UD or MXT 2952TD. These are the ones that are belonging to the TD and the UD generations. The generation actually introduced differential mutual sensing into the capacitive technology, which helped us to increase on all of these parameters. Before this technology, we could go up to maybe 3 millimeter glass. Now we can do up to 10 millimeter glass, for example. Before the technology, we could do only single finger. Now we can do multi-finger, and multi-finger gloved in presence of moisture, for example. This is a big improvement from what we had in earlier series. So for now, I would say go for TD and UD series of the MaxTouch brand in Microchip.
That sounds like really helpful advice. I'm just interested. I mean, we've talked a little bit about some of the things people have to consider. So as well as making sure the touch works and doesn't detect rain as being a touch, you also talked a little bit about things like UV filters. I mean, what are the things that are not directly related to the touch sensor that engineers need to consider if they want to deploy touchscreens that are going to be robust and reliable outdoors?
So other than the touch controller, I think another key thing would be working with the right display partner. And this is also one of the best things to work with Microchip, because we can actually introduce you to such display partners where we have proven track record working throughout many years that can deliver this type of performance. So what happens is that, as I explained the stack of the display itself, there is a skill to it. The layers that comes in between the finger and the touch screen itself needs to be in a particular order. This cannot be a random order, and a good touch display provider would have experience throughout the years to give you the right stack build up, which is actually related to also the touch controller performance, because the way you build the physical stack will directly affect the performance that you can squeeze out of the touch controller. So in this whole world of touch, there is the skill to make the right stack, and then there is the skill of the display maker to get the right performance out of the touch controller. The way we give our touch IC is that it's pre-programmed. We don't really ask our users to program it, but there is a configuration that needs to be sent to the touch controller for it to be configured for an outdoor use. And this configuration, the skill of configuring it with the right physical stack up to get the final performance out, is also a skill that a very good touch display provider will possess. So I would say, apart from choosing the right touch controller, try to find and work with the right display provider. That will save you a lot of time and a lot of cost.
That's great advice, Vivek. I mean, we've covered a lot in this discussion, from, the control all the way through to the physical stack up of the display. What would you say, just to summarize, would be the most important thing to remember about building rugged outdoor touchscreens?
I would say, if you are going for an outdoor rugged touchscreen, think about your performance parameters well in advance. and choose the right touch controller, because it can save you a lot of cost, a lot of repair, a lot of unhappy users if you do it in the forefront than to start with something cheap that maybe fits your cost at the beginning, but then does not give you the best performance, and then your users end up suffering with that.
That's really great advice. I mean, before we let you go, Vivek, we always like a little tip for the listeners. So what would be the best bit of engineering advice you could give people listening to the podcast?
Choose the right touch controller and choose the right display partner. They go hand in hand. And if you could do that in a very efficient way, you can work with Microchip support. We have worldwide support. We have field engineers in every region. If you are designing something, most of the times engineer ignore the choice of the electronic IC components on the board, and they work directly with the final display providers. But more often than not, I had the issue that they were not happy with that, and they eventually realized if they would have involved us at the beginning of their design and took advice from our field application engineers and our application engineer expertise to choose the right touch controller, they would have given the first version already at very high quality to their customers. And my advice would be, work with us, work with the IC vendors and touch suppliers at the early stage rather than the later stage of your development.
Perfect. I love that. I mean, Vivek, I just want to say thank you for your time and all your insights. It's been really interesting. If people have listened to this and they want more information, or perhaps they want to get started on the design, where's the best place to go for them to get more information?
I think the best way to remember all of this is remember the brand MaxTouch. We have the maxtouch.com website. On our website are all the industrial products for outdoor performance are listed already over there. There is a contact form that is available there. If you fill in your query over there, it will go to the right sales contact or the engineering contact in your region. If you get in touch with that, then I think it's more than enough, and they will contact us and we can provide you all the information.
Perfect. Vivek, thank you so much for your time, and thanks for explaining why Microchip is rugged outdoor touchscreens.
Thank you.
Thanks for listening to the Microchip Is podcast. Please follow us on your favorite podcast platform to keep learning about the many technologies, products, and people that make Microchip what it is today. Look out for our upcoming Microchip Is podcasts and our new Beyond the Microchip podcast series.